Ji said this is going to be a very important session because like last time from Monday onwards, from session 5th onwards, we have started with the technicals related to the vehicles, and where we have read about the chassis and other components. To be very frank, the main iron components and the structural components we have spoke about. Now we will go into the depth, or we will start with the primary components of an electrical vehicle. Primary the components which differentiates an EV from a normal conventional vehicles. So today we start with the uh, controller of the vehicle. I'll just share my screen. Nabangshuri, just to check, like my screen is viewable to you. Can you see my screen properly? Just to check. Hello.
Yes, you are audible.
And you can see my screen properly?
Yes, 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 it is visible.
Yeah, thank you, thank you, thank you. That was what I wanted to check. Okay, so students, like as I mentioned, that today we will be getting into the primary components of the electrical vehicles. So if you speak about the most primary components, so we normally rate the three primary components of an electrical vehicle are controller, the motor, and the battery. So these three components are something that differentiates a vehicle for EV from a normal conventional vehicle. So we will start with uh, the controllers today. So as we have discussed like earlier also, we said that controllers are the brain of the vehicle. So whatever the output decisions are, that they collect the information from the different parts of the vehicle, and they accordingly they give the output and they receive the analog signals through the throttle, and then they give the final signals to the motor, how it has to perform, at what speed it has to perform, and also other like controlling components, like it also takes care of the safety features of the vehicle, how at what points, at what critical points it has to take care of the vehicle, so that no any further any damage to the vehicle or the person driving doesn't occur. So all these would be done by the controller. So we'll be discussing all of them one by one. So these would be the main components which we will be touching on. Normally the EV power system, then the what exactly a motor controller is, and function of a motor controller, how does a motor controller work. So all these components we will be discussing today. So as like when we were giving an overview of the vehicle, we already have given a glimpse of like what primary main components of an electrical vehicles are, and electrical and if you talk about the controller, this forms the major component of an electrical vehicle. So all the decisions, all the safety parameters, and collecting information and giving a proper output, all this would be dependent upon the like controller. If you like compare it with any computer, then you could say you could say the CPU, in a term you could say that it is the CPU of a computer or a brain of a human being. So it entirely it controls the vehicle. So EV power system. The power system of an electrical vehicle comprises two components, motor and controller. Motor provides the power. A controller controls the application of this power. In comparison, the power system of IC comprises an engine, carburetor, oil pump, water pump, cooling system, starter, exhaust system, etc. So if you talk about the power system and electrical vehicle, the main two components are the controller and the electrical motor. So why we say like they forms the power system, they doesn't form the complete powertrain that we call, but these are the power forms the chief components of the power system. So like how a vehicle would be behave, the decision would be taken by the controller, and accordingly it would be sending the signal to the motor to perform. So the end performer is the motor, the recipient of the signal through a throttle is the controller, and at the end which would control the entire functioning of the vehicle. So how a vehicle would be performing, and what condition a vehicle would be performing, and if a vehicle needs an acceleration. So whatever analog signal that we give, the first it is received by the controller, and then it gives accordingly, it gives the signals to the different parts of the parts of the vehicle to perform accordingly. So main function controller is to control the functionality or the control the performance of the motor. So how it has to, how it reacts. So why a controller is needed? You could say that without a controller, say if I have only a motor and I say remove the controller from the system and only I give a signal and the motor runs, that if we talk about, that is not possible in fact, because it won't be that conditional specific, it won't be conditionally specific. So when a vehicle is running on a road, there are a set of parameters they which keeps on changing. So accordingly these parameters would be changing. Someone has to take the decision, like in what condition how the motor has to perform, because motor is not intelligent. Okay, so motor is not intelligent, it is just performance oriented, you could say. It's just function is to like just to give an output in the form of the rotation of the vehicle. But this rotation cannot be like, it cannot be a linear rotation, linear movement. The vehicle cannot move linear movement. If you want to say move from one place to another, it can't be that we start from our house and we reach to that place like with a constant motion or with constant conditions. So in front of your house the road might be good, but when you reach there the road might be different. There might be some gradient might be there, higher gradient road might be there. The road might be not as smooth as it is in front of your house. So reaching from your house to your destination, the conditions would be changed. Not just the road condition would be changed, the traffic would be changing, and several other different things would be changing. So motor is not intelligent to take that decision. So motor doesn't know, motor doesn't grab the information of the conditions. It just gives an output. So the component who not only receives the conditions, it processes that information, and accordingly it gives an output signal to the motor to perform. Okay, so same is as the case with our body, our hands and legs. If we talk about, they are when a signal is given to them, either if it is if we have to walk from one place to another, move from one place to another, our legs will do that duty, and if we have to pick something, our hands would do the duty. But who takes ultimate decision for us? It is the brain who receives information. Say receiving recipient could be, it can receive information through eyes, it could receive, or through ears it could receive. So 5 sense organs that we call, through it through all those organs our body receives signals. The signal reaches to the mind processes, and then it gives output signals to different parts of the body to perform. Same is with the vehicle. So analog signals, I give some signal through my throttle, or some conditions have developed on the road, or internal conditions have developed in the vehicle. So that information will reach to the controller. The controller will process those information, and accordingly that will process with the help of that information, it will give an accordingly output it would give to the motor to perform. So there might be an abrupt condition. Say if you talk about some, say some condition has formed, which needs the vehicle to be immediately stopped, or the power needs to be cut down immediately, it needs to be cut down. So that kind of programming will also be there in the controller, so that the immediate immediate reaction, how it has to be done, those provisions will also be there. So controller will take care of everything, the safety of the vehicles also, and the performance of the vehicles also, the output performance of the vehicle also. Say so in if we talk about a normal IC engine vehicle, if you talk about, so it has carburetor, oil pump, water pump, cooling system, starter, exhaust. All these mechanical parts are there in that vehicle, and that too takes these. What does these parts do? These parts take care of the performance of the vehicle. So, and performance and the in fact, performance of the vehicle under safe conditions. So, let's say oil pump, water pump, cooling system, they would be maintaining the temperature of the engine, and the starter, the exhaust systems, they will also be taking care of the entire system, so that the vehicle performs in a better way, and takes and the safety of the vehicle is maintained. Same, if all these functions are in an electrical vehicles done with the help of the controller and electronic device, the controller. So several we can we can go we can cut off these 4 or 5 parts that we have spoken about in IC, normal IC engine that we use. We can go away with these parts in EV with the use of only controller. So what is a controller in normal language? If you talk about, it is the brain of EV. We explained that how it is a brain of the EV, because it receives information, it processes the information, and accordingly it gives the output to the motor to perform, or even to other parts of the vehicle under safety norms. It will also act as a safe device for the safety of the vehicles also. So it is a combination of power electronics and microcomputing elements. It operates between battery and motor. It tells the motor and other devices that what to do based on the input received. So as we spoke about it, so it is a what is a controller made up of? It is made up of power electronic component. There would be a lot of resistors would be there, then capacitors would be there. There is also a microcontroller into it, which is programmed accordingly to take care of the conditions, how it has to react accordingly. And at the same time, it is connected between the battery and the motor. So the power supply is attached to the controller, then the power supply moves to the motor through the controller only. Okay, so this the power supply that is received, accordingly, like how much has to be given to the motor, the output goes through the controller to the motor. Okay, so in between, this intelligent controller or the controlling system is connected. And if we talk about the functions of an what are the core functions, if we talk about, so it tells the motor and the other devices what to do based on the input received. So we have said that it receives the analog signal, it receives, it processes it, and it gives the output signal to the motor and the other parts of the vehicle to perform accordingly. Okay, so it is normally the core function of an electrical bike controller is to take all the inputs from the electronic components, electrical components, electronic components, and then gives the output accordingly to other parts of the vehicle to perform accordingly. So it also takes at the same time, it's not only that it will receive information from the throttle and give output to the motor. It is not limited to that only, but it will also take care of the some as we spoke about, some emergency situations also it will take care of, like over voltage protection it will take care of, low voltage protection it will take care of. So why low voltage protection? Because if the voltage goes below a normal limit, the power the current drawn would increase, and that will ultimately, that might damage the output circuit also. So that case will be taken care of. Over temperature protection is also there, because the entire current that would be used by the motor flows through the controller. So there might be condition when continuously, if the current is flowing at the highest level, or the if you talk about the ceiling level, if it is flowing, then it might heat up the controller. So there would be temperature sensors also inbuilt in the controller, which will if the temperature goes above a certain limit, because every controller is rated for certain current limitation it is rated for. So if it goes beyond that, then also the controller will cut off, and if will cut off the power supply to the motor, because at the end the major power from, or major current from the electricity from the battery would be utilized by the motor only. The ancillaries will be requiring a very small amount of power. The motor would be consuming the majority of the power, so the heating will also will be happening because of that. And that those cases could arise either because of like under voltage or because of heavy loading. The cases could be there that we are loading the vehicle more than the permissible limit, so that could also cause the heating of the controller. So typically you can see here, like in between you can see the motor. So this all these elements that we are showing it over here, these forms the main main components of an electrical vehicle. Or if you say, if you want to convert your vehicle into an electrical vehicle, so these would be the primary components. So motor is there, then you have this controller. Here you can see this is the controller with multiple output wirings, even input and output, both wirings are in here. So an input will be coming from the battery, and then several outputs would be and then input will be coming through the throttle, and several outputs would be going out of this controller. Then this is the throttle is there, then ignition lock is there, then say front lighting is there. This is for power transmission. Say this typically is a kit for a cycle, like if you want to convert a normal cycle into a electrical cycle. So this is an entire kit if you want to convert it. So the purpose was to show here is that like how how a controller forms the part of the main components if you want to convert a normal bike into an electrical bike. So the controller transforms the batteries DC into AC for AC motors only. So it is taking DC from the battery, but what happens is when output is given through the controller, so the output is given there are a set of MOSFETs that are being used in the controller. So output goes out of those MOSFETs. So the output could be either in the form of a square wave or in the form of a sine wave. So we normally at times we call it it might be we call it as an alternating current also, we say, but that is again in fact a DC output, but that might be either in the format of a square wave or a sine wave. It regulates the energy flow from the battery. So what energy or what power has to be given to the motor is regulated through the controller only. It configures motor speed and torque after receiving feedback from VCU, so vehicle control unit. So to clarify here, the speed of a vehicle is dependent upon the voltage, and the torque is dependent upon the current. So accordingly the controller takes the decisions what output voltage has to be given if you want to increase the speed, and if the torque has to be changed, then it is the current that has to be increased or decreased. So it is responsible for the current and voltage of the motor. So as we spoke about that the undercurrent, the overcurrent, and the requirement of the voltage for speed maintenance or of the speed, these regulations would be done through the controller. The controller also reverses the motor rotation, so the vehicle can go in reverse. So the controller can also you see that this is a very you can call it as a USP of an electrical vehicles, that you can also drive in reverse direction, but that would be with a very low speed as compared to what you speed when you are front, when you are making your vehicle move front, in a normal direction, so the reverse speed would be like 1/3 of what the speed would be when you are driving in forward direction. It converts the motor to a generator so that the kinetic energy of the motor can be used to recharge the battery when the brakes is applied, known as regenerative braking. So the regenerative braking is again a feature inbuilt in controller only, because there are vehicles which could have a controller without regenerative braking on. So this could be can be an inbuilt feature or can't be an inbuilt feature. So controllers can be without regenerative braking, they can be with regenerative braking. So if there is a regenerative braking, so what that will help you is when you are applying brakes. So if when you are like trying to bring your vehicle to halt from a moving position, so that kinetic energy, part of the kinetic energy would be converted, will be converted into electrical energy, because your motor, because of your motor will start performing as a generator, and this energy that would be generated can go can reverse direction and go back to the battery and result into the incremental charge of the battery. So your battery, if say if you are regularly applying brakes and if you're moving to a like longer distance, then there might be cases where you can enhance your mileage of the vehicle by 3 or 4% you can increase. So that is a feature which is inbuilt in the some controller, and it might not be there in some controller. So it is again an optional one. So regenerative braking, it is a process in which the motor is used as generator to recharge the batteries when the vehicle is slowing down. So as we explained, when the vehicle is moving, it has some kinetic energy. And when we try to bring it at halt, the kinetic energy is converted into, say, it's converted into an electrical energy, because the motor we are trying to we are trying to because when you are trying to bring it into a position of rest, there would be there would be an EMF generated in the opposite direction to bring it to the position of the rest, and that EMF will make the motor act as a generator, and this generator would be generating power, a part of which will go into the battery, will go back into the battery and will recharge, will result into an incremental charge of the battery by 5 to 10% of efficiency, or the mileage of the vehicle can increase due to regenerative. So we might question, or we might say that, so applying the brakes will increase the battery. It's not so, because this energy might have been lost, like in some or the other form. It might have been lost by maybe in form of the heating of the vehicle, heating of some parts, or say like slippage of the vehicle rear tire, or some other form. This energy might have been lost, but what we have done through regenerative braking is we have tapped a portion of that energy, which in any way might have been lost, because this kinetic energy of the moving vehicle now is converted into when it comes to a position of the rest, this would be might have been lost in some or the other format. So we have, through regenerative braking, what we have done is we have tapped a portion of that energy into a usable form, and we have made our battery charge by 5 to 6%. We have been able to charge it, and so that has helped us in increasing the efficiency of the, or helped in increasing the mileage of the vehicle. So we take a case that we have two vehicles, one is with the regenerative braking and the other is without regenerative braking. So the vehicle without regenerative braking, say we are moving from same points, and we have the same destination, moving through same conditions from point A to point B. So a normal without regenerative braking, we would be applying equal number of brakes, but that energy would be lost, and say our vehicle at the end, when we see that the position of the or we position of the battery, when we see it might have drained, say 60%, it might have drained. And but when we have an option of regenerative braking, and we see that in that vehicle, if we check, we might see that the battery position might be 65% or 67%, it might be there. So that incremental, that loss, we have been able to tap it and have been able to have an incremental charge of our battery. During regenerative braking, some of the kinetic energy normally absorbed by the brakes is turned into heat. So as we said that if you don't have it, it would be lost in the form of the heat. But now we are making it and we are tapping it and we are making a use of that energy. It is then converted to electricity by the motor or controller and used to recharge the battery. So if we have a provision in the controller, we will be able to use a part of it. Instead of it getting lost in form of heat, we would be making a use of it. It increases the range of an electrical vehicle by 5 to 10%. So as we spoke about the two vehicles, the same vehicles with regenerative braking and without regenerative braking, when we see which have like traveled in the same conditions, have applied same number of brakes, so we would see that the battery the charging position of the battery with regenerative braking will be better than the battery with non-regenerative braking. It also decreases brake wear. So definitely, how does it decreases the brake wear? Because if we don't have a regenerative, the entire energy will be lost in the form of the heat. But here, the energy to be lost will be minimized. So the wear and tear or the effect on the brake pads or the brake system would be reduced. It reduces maintenance cost. So maintenance cost definitely, because it's bringing down the pressure on the braking system, the brake pads you could say, or the caliper and the other parts of the braking system. It is bringing down the pressure, so the maintenance cost will also come down, because normally what happens is the main maintenance that comes into a vehicle is in the form of the brake pads, because those are brake pads, the tires, which are directly which directly absorbs the road condition, or which are very frequently used. So by regenerative braking, we are exposing them to less heat, and which will result into that better performance and lower maintenance. So this is like a small script we have been trying to give you a glimpse of like how regenerative braking will work. So when you have applied a brake, the vehicle will try to come to a position of rest, and when it will be coming into a position of rest, so as we spoke earlier also, in electrical vehicles, when we are braking the when we are applying the brakes, what we are doing is we are also cutting the power supply to the battery. So there would be, as we spoke about, normally in a vehicle, like charging and discharging at the same moment is not permittable and generally doesn't happen. So when we are applying the brake, the output from the battery is stopped to the motor is stopped, and this regenerative braking will come into effect. So it can like as we said, it can only be like one way, either charging or discharging. So application of brakes, we are like discharging, we are stopping in any case by applying the brakes, and this regenerative can take care of can charge the battery to an incremental like 6 to 7%. It can increase the charge of the battery. Incremental mileage we can get with the help of the regenerative braking. So if you talk about a normal controller, if we talk about, there are four different circuits are there like into the controller. So there are the controller is made with the help of different circuits, you could say. So if when we will be coming like to give a practical demo to you guys in Osmani University, we will be featuring you like controller. We will be opening the controller and we will be showing it to you. So there you would notice that the controller is made up of different types of like circuits. So they are divided into different portions, which forms the different circuit. What are these circuits? These are like one is analog digital circuit is there. So analog, what does it do? Analog digital circuit, it receives the signal from the throttle and converts that analog signal into a digital format. Then there are pulse width modulation generator circuit. What does pulse width modulation circuit do? It receives it receive the analog to digital circuit, which has converted the signal into digital form, will send it to the pulse width modulation circuit. So what pulse width modulation circuit will do, that the digital signal, that it will study, it will process it, and it will amplify, and it will like accordingly, like you could say same intensity of pulse width modulation, pulse width would be generated by this pulse width modulation circuit. And uh, then a power circuit is also there. What does a power circuit do? So power circuit would would be directly connected to the battery, and it will be always it would be normally it would be taking care of like what is the voltage of the battery, whether it is under it has not gone under the permissible unit, or it has not overcharged above the permissible unit. So it is directly monitoring the battery, and at the same time the output also goes through the power circuit. And so these would be taken care of by these three circuit that we spoke about. So power pulse width modulation circuit would be there, analog digital circuit would be there, and this power circuit would be there, and at the same time there would be under voltage protection circuit would be there. So that would take an overcurrent protection circuit would also be there. So these all circuits working, forming the part of the controller, will take care of the entire vehicle. So protection will take care of the protection, the power circuit will take care of the input and the output power, the pulse width modulation circuit will take care of the pulse that has to be generated, and that pulse will act as the triggering of the MOSFETs. And this overcurrent and overcurrent and under voltage that we spoke about also takes care of the safety of the vehicle. So what is a pulse width modulation circuit that we spoke about? So typically a controller, if we speak about the output to the motor, is through a set of MOSFETs. So what are MOSFETs? MOSFETs are power electronic devices, like which acts as a like regulator, which are kind of regulator. So you can very precisely you can control what would be the output. Output would be flowing through them. Okay, so the output that would be going to the motor, that would be going through those set of MOSFETs only, and those MOSFETs could be controlled. The output could be controlled through these pulse width modulation. So the analog signal that has been received, through the throttle, that will come to analog digital circuit of the controller, that would be converted into a digital signal, that would be converted, that would go to the pulse width modulation portion of the controller. From there a pulse, equivalent amount of a pulse would be generated, and this pulse would act as a triggering of a MOSFET, as how much like voltage has to be, how much voltage output voltage would be there through the controller to the motor. So pulse width modulation would act as a it would be like helping in switching of the MOSFETs at like different intervals, like when it has to be switched at what voltage has to be what has to be the output. So the output would be, the output through the MOSFETs would be controlled through these pulse width modulation circuit. So when we enter a room and switch on the fan, after some time the fan attains a constant speed. Now switch off the fan and let it come to rest. Switch on the fan again, but this time toggle the switch between on and off quickly for some time. We observe some reduction in speed of the fan. Repeating the toggling for some more time, and we observe that the speed keeps decreasing with the increase in toggle, and this is the main objective of the pulse width modulation. The main objective of pulse width modulation is to vary the signal average or RMS value by modulating the width of the signal in its period. So as I said that what does a pulse width modulation do? The analog and digital signal gives the signal to the pulse width, and it again like generates a equivalent amount of pulse that acts as the triggering or the switching of the different MOSFETs that forms the power through which the output to the motor receives the output to. So terminology, duty cycle. Duty cycle is the active time of the cycle to time period. We can conclude that the signal output value can be varied by varying the duty cycle of the pulse. So like if you see here the duty cycle, see in first case 0% duty cycle. Okay. In second case, if you see it's 25% duty cycle. 25% in a sense like it has formed four waves in the time period, in the normal time period. There has been no signal from in during this time period. So zero duty cycle. So here also we have some time period, but four waves have been generated. So 25% duty cycle, this is 50% duty cycle, 75% duty cycle, and 100% duty cycle. So these are various duty cycles and their average values that we are trying to show you. So active time of the cycle upon the time period. So if you talk about, say, this is the first interval that if we speak about the first interval, then you could say this is the active time of the, you could say active time of the signal. So the 5 voltage, or you could say the pulse, if you see it was only for a 25% time of the this active time of the cycle. So we call it a 25% duty cycle. If we talk about this wave, it was it has produced for 50%, the 5 voltage that we want to see, it produced for 50% of the duty cycle time period. So this is the entire time period. If we compare in all these 1 2 3 4 5 conditions, if we talk about, so this was for the 5 voltage pulse was generated for zero number of times between this time period. It was generated for 25% only for during this time period. So the duty cycle is 25%. If you talk about this this graph, if we talk about, so during this time period the wave was generated, the 5 volt pulse or the signal, if you talk about, it was for 50% of the time. So we said 50% duty cycle. If you compare it here, it is for 75% time, so it is 75% duty cycle. If you talk here, so from here to here, it was for the entire time period, the signal of 5 volt existed. Okay, so it existed. So I would say this is a 100% duty cycle. So duty cycle is, this time period is fixed. So for how during this time period, for how much time the pulse is active or the pulse is there. So that would say that the duty cycle, that would define the duty cycle of the controller, you could say, or the duty cycle of any component, it would say. Modern controllers adjust speed and acceleration by pulse width modulation. So as we said that a pulse with the help of the pulse width modulation, what happens is the output voltage through the controller, that could be controlled, and we could better control the motor with the help of the pulse width modulation. Switching devices such as silicon control rectifiers rapidly turn on and turn off the electricity flow to the motor. So silicon control rectifiers, if we talk about, these are nothing but the MOSFETs that we use in the controllers. What they do is they help in the switching is very so as we said that these MOSFETs in the controller, they act as regulators. They act as regulators. So the output could be controlled, and it could be controlled much precisely and very, very fast. It could be controlled. So reaction time is very low. So if the condition arise that that there is a gradient in the vehicle, and at the same time your speed is coming down, so the voltage would should be accordingly, the output voltage should be accordingly. So that would be taken care of instantly. So the outer condition would be accessed, and that would be studied, and accordingly the reaction would be there through the controller. So these four circuits that I spoke about: analog digital circuit, then pulse width modulation circuit, over voltage over current under voltage circuit, and the power circuit. These circuits along with the MOSFETs and you could say a microcontroller, a programmed microcontroller, then another electronic items like your capacitors, resistors, or there would be diodes, and like other ICs would be there. Those everything together form a controller, entire controller they form. So modern controller adjusts speed and acceleration by pulse width modulation. Switching devices such as silicon control rectifier rapidly turn off and turn off. We spoke about the MOSFETs. High power vehicles are very short intervals, which means the current is turned off for a very little time. Has very short intervals, which means the current is turned off for a very little time. So if you talk about the high power vehicles, that would be constant, there would be braking and there would be accelerations. Okay, so they have to be precisely, it has to be very precisely done, so that the reaction time is very low, so that the performance of the vehicle is not affected at any point of time. So low power speed vehicles are have very large intervals, which means the current is turned off for more time. So high power, say if you have broken down the speed, or if you are at the position of the rest, and when you are accelerating, it has to accelerate at a very fast speed. So within seconds, it needs to reach to its maximum speed. So for them, the interval, the turning off and turning on interval is very low. But if you talk about low speed vehicle, yes, they would be accelerating at their they would be accelerating accordingly. They would be taking their good time to accelerate, and so the on and off interval is higher in case of a low speed vehicle. You can yourself see that this period that they have mentioned. So uh, there would be a longer interval. When they come to the position of the rest, they will reach to the peak performance or the peak speed. Okay, after a longer interval. Say if they have come to a position of rest, and then they would be taking this good time period between their position of rest to the top speed. But if you talk about like high power vehicles, they would be like coming to the position of the rest for a very short time, and then again they will pick their the highest top speed they will reach very fast. So this switching, this difference in the switching is taken care of by the controller. So these are the key features if we speak about, or the key advantages or disadvantages if we speak about. So a good controller should have high power density. Okay, so it should be in a position so that it could it doesn't get heat up. So it should be rated in such a way that it passes on the or electrical energy or electrical power from the battery to the motor, and doesn't get heat up. So that, because if there is a constant heating in any electronic part, the performance also comes down, and there are high losses due to the heating. So any electronic component should be so designed that the heat developed is very low, so that the efficiency is also increased and there are less losses. So we could say that yes, more and more energy is converted into a usable form. Applicable for induction motor or permanent magnet motor. So for induction motor also, and for permanent magnet motors also, it should be applicable for both. So for induction motor, normally we could term it not a controller, but we could say it could be a variable frequency drive. So the speed could be controlled by varying the frequency. So that could be there, or it could be an entire set of inverter, a controller, and the same VFD that we are calling, that could be a vehicle control unit, which would also which will also form, this inverter will also form the part of that. So it would be a full consolidated unit, because when you are trying to move an induction motor and through a power supply from a battery, so this DC has to be converted into an AC. So it has to have a provision of converting that AC first into DC first into AC, and then that AC, that the controlling of that AC could be done, and then it is given, the output is given to the motor. So that should be there, because AC can, if you talk about AC motors, the controlling is typically normally very simple, because in industry already we are using AC motors which are controlled at a very precise level. They are controlled. So if there are very sensitive processes in an industry, so the controlling is also that precise. Already we are using like induction motor, and their controlling could be easily done. And normally in industry they are done through variable frequency drives. They are done. So same process could be applied in a vehicle also, but that could have a consolidated vehicle, and we could, instead of saying controller, we term it as vehicle control unit. So that will have in it the inverter. It will have all the controlling mechanism will also be there into it. Over temperature protection, as we speak about, a good controller should have an over protection temperature, because increase in temperature is directly proportional to either your rated current is higher, the current that is flowing is higher than the rated, or there is some fault which is causing more heat, development of more heat. So if the temperature increases from a certain level, the controller should have a provision that it is cut off from the motor, so that we can we have when we have a time slot when we can monitor the vehicle, and we can see everything. And when we are fully confident that because of no external fault, the current, the high current is flowing, but it might be because your motor is low rated. Okay, and you are either driving on a gradient, or you are driving overloaded condition. So those conditions will again result into high current flow, which will again result into heat development. So those conditions can be rectified, and you can again run the vehicle. So this would be kind of an indication or kind of a warning alarm to you. So a controller would be giving that you have to go for a diagnosis of the vehicle to further continue your journey. And over voltage protection, over current protection, we spoke about, that is an inbuilt circuit into a controller which takes care of, because these are very important features. Already in a battery, the BMS has the feature of over voltage and under voltage cutoff, and over voltage cutoff, they have the feature. But additionally, again, controller also have that feature. So we have a dual safety when we are in an electrical vehicle. If in some condition, if the safety of the BMS is bypassed, then controller can take care of that. So easy and quick assembly with EV propulsion system. So it should be, it has there are if you talk about a two-wheeler or a three-wheeler vehicle, if you talk about, so there would be a lot of number of wires that are coming out. They could be for the supply and to the output to the motor, and then other controlling wires would be there. But it should be properly indicated, and they should be properly color coded, so that during assembly it doesn't take much time, and easily anyone can assemble. And applicable for BEV, PHEV, REV, HEV, all kind of vehicles, whether it is electrical vehicles, fully electrical vehicles. If it is an electrical vehicles which could be externally powered, it could be there, or it could be a hybrid electrical vehicles. It should be common for everyone. It should be applicable and performance oriented for any kind of vehicle. Controller are used due to the demand of the operating system, installation requirement, or to increase motor efficiency. So in any case, controller we would require for any electrical vehicles, but there could be some additional features in the controller itself. So at the same time, all these features that we spoke about, in addition to them, there could be the feature where you could have you could locate your vehicles through a controller also. So you could have a telematic device inbuilt into it, so that you can track your vehicle. And at the same time, there could be your controller could be CAN enabled, or it could have a provision where it can emit data to you. So in battery also you can have, and at the same time in controller you can have. So say at some position your vehicle, it is running at what speed, what is the battery position of the vehicles, what is the location of the vehicles, how much per kilometer, how much electricity it is consuming. All those data could also be emitted your controller could have that feature. This is normally not there in a normal controller, but those all features can be built into in a controller. So at the not only performance of the vehicle, but it could also be a data center where it could emit data to you. So it could be connected with the internet. You could have a like you could insert a sim into it, and that it can start emitting data to you. So which data you can like collect it, and you can judge, or you can see the entire performance of the vehicle, say from moving point A to B, or what are the like what are the before this we spoke about like drive cycle we spoke about. So drive cycle, what does drive cycle helps us in improving the vehicle? And because we when we collect the data pertaining to a certain vehicle, like we can collect the data, and we can like when we are going for some future additions to the vehicles, or when we are going for the like design of the vehicles, we can use those data. So controller can have that feature where it could collect all the data, all the data when it is moving from one place to another. So in what condition it is moving, how it is performing under certain conditions. Say I know a road which is certain gradient. For such a long distance it has some gradient. So 1 kilometer if I have driven the vehicle, so there is an inclination, and it has like inclined, and it has it has a certain elevation it has reached, say 20 meter or 30 meters. So I can calculate how much is the gradient of that area. So in that condition, how it has performed, what has been like effect on the battery. So all those data can also be all those data can be uh, the controller can have a provision where it can emit all those data to you, and which can help you in like increasing, enhancing the uh, performance of the vehicle. So again, as we saw in the earlier slide also, so these are again some components of controller, and all these components, if we speak about brake lever sensor, it gives an input to the controller. Then these different again these different PAS components are that they will also give an input to the controller. Throttle is again an input device. Battery, it is an input and output device. So it also receives information from it, and it also gives information to the vehicle. What output information it gives? Say if it finds that the voltage, the under voltage, it is the voltage of the battery is under voltage, then it will give a signal, output signal of cutting it down. It won't receive power from the battery. So it is an input output. With battery, controller has an input output communication. Motor, it has input output communication. In output communication is the how much voltage it has to leave, and at the same time it is also taking care of the input data in the form of like what is the road condition. Accordingly the torque has to be increased or it has to be reduced. So it's again motor. With motor, the control has an input and output communication there. With display also, it has an input and output communication. So output communication could be in the form of SOC, and all those input communication can be like how much whether when you have turn on your ignition, when you have turned on when you have switched on the vehicle, then it gives an input. The display will give an input to the controller that yes, the vehicle is ready to move. So all so the controller can communicate like one way or two way with the other all the components of the vehicle. So either it could be a one-way communication of only receiving the information, or it can be a two-way communication, receiving information and also giving output to the components. So how does a motor controller work? So typically talking about the working of the motor controller, as we discussed that a motor controller has 4 different circuits. The analog digital signature circuit is there, then pulse width modulation circuit is there, power circuit is there, and under voltage and overcurrent and under voltage circuit is also there. And also it forms, it is it forms a component of components like MOSFETs, microcontroller, and capacitors, resistors, and other IC circuits are there. So like microcontroller is an inbuilt chip, and it is programmed accordingly to so that we know that so that the controller knows in what condition it has to perform how. So microcontroller is that through analog digital it receives the signal pulse width modulation, that the signal that it has received, the analog signal that it has received, which has been converted into a digital format, that will be flown or sent to the pulse width modulation, which will study that signal, will accordingly amplify that signal, develop a pulse width, will develop a pulse, and of which the duty cycle that we have discussed. According to the duty cycle, that will help in switching on the MOSFETs. And what MOSFETs are doing, MOSFETs, the entire output from the controller to the motor goes through the MOSFETs. So they would help, they would act as the switching of the MOSFETs. And all these are again different there would be set of there would be set of some safety, like as we said, that over voltage, under voltage and over current circuits will also be there, which will take care of the safety of the vehicle. So if there is a permissible under voltage for a controller, so if the voltage the receiving it compares the voltage of the battery voltage, and it finds that it is below the cutoff voltage, then it will not allow that, it will cut off the battery from the it will cut off the battery power in that condition. And at the same time, the overcurrent, if the overcurrent is flowing for a very longer duration and the controller is heating up, and it also it will cut off the power supply. So either you have to rest the vehicle for some time, reset the controller, and then you have to again move. But why this condition has arrived? Because there is always a root cause for any fault or the indication of the fault. So you have to find out the root cause, you have to eliminate the root cause, and then only you have to again start your vehicle. Because if you continue with that fault, with the resetting, the controller will think that yes, you have because if something is happening due to say overloading, if it is happening, the controller cannot remove a person or remove load from the vehicle. It has to be done manually, it has to be done. So if you reset the controller and you start moving again, the controller will think that yes, you have rectified the problem and you have started your vehicle again. But if that persists, again it would be causing the problem with the vehicle, and in long run it would be affecting the vehicle. So motor controller usually supplied with AC power. So this is typically for if you talk about normally a four-wheeler, if you talk about, so the input can be an AC. So, and there we might not be calling them controller, we can call them like vehicle control units, we could call them, or we could have different names. We could even say VFDs, we could call them VFDs, but typically we call them vehicle control unit. The power that comes into a controller is at a set frequency. The motor controller first turns that AC to DC, and then turns the DC back into AC at the right frequency. It uses a device called a rectifier to make a DC current. So these DC currents that that we are talking about, what they are doing, there are again different set of circuitries also there. Say there is a circuit which will develop a DC current of 5 volts. So this 5 volt will be like supplied to this 5 volt, through this 5 volt would be supplied to the throttle, and at the same time it will also be supplied to the hall sensor of the motor. So this way it will communicate. So this 5 volt signal, this would be like accordingly amplified. So the information that the controller will be receiving through a throttle or from a hall effect sensor of a motor, that would be in the format of a DC voltage only. So in the range of from 0 to 5 volt only it will be receiving, and accordingly those signals would be like received by the controller, and it would be taking accordingly, it would be taking that signal would be accordingly processed, and the controller will be taking accordingly accordingly will be giving the output. Inside the rectifier diode that function like a one-way valve, when the AC in the negative half of its cycle a diode. So this is normally part of the controller that also has a rectifier in it. When the AC in the positive half of its phase, so this is a kind of a rectifier as
Govind, your voice is not there.
Sorry for it, sir. Sir, sir, your voice is not audible, sir.
Govind, are you there?
Yeah, I'm
Yes,
there.
sir.
Yeah.
Is it fine now?
But I think your screen is not visible.
So where we missed out, like there was some. I think
Your last slide.
1 second, 1 second. Is it viewable now?
No,
You can see it.
no.
1 second.
I think you need to stop screen, then again share the screen.
Am I audible? First of all, am I audible?
Yes, you are audible. You are very much.
1
audible.
second. I'll share the screen.
Yeah.
Can you see the screen?
Yeah, now it's visible.
So sorry, but like where I missed it, if you can like tell me, I will start from there again.
Your last slide.
This slide.
Yeah.
So hope I have like I was not audible for a very longer time. It was
No, not longer time. It just happened. Just 2 minutes back.
okay. So like controller that we were as we are talking about the controller also, as we spoke about these basic AC/DC circuit, then pulse width modulation circuit, then overcurrent and under voltage circuit, then power circuit. In addition to them, there are also some circuits which develop a 5-volt supply also. So through these 5-volt supply, what happens is the controller through these 5-volt supply, the controller communicates with the throttle and also the Hall effect sensors of the motor. So the signal from Hall effect sensor and the throttle will be sent to the controller in the form of these voltage, this 0 to 5 volt only. That voltage will be studied by the controller properly, and accordingly that the controller will be sending the output. So here like we have given a like short description about how because there are also rectifier signals where we need to control where we need to convert AC into DC. So the rectifier signal is there. So normally what a rectifier do is converts an AC to DC. So both in AC we know that if it is a sine wave AC, then there is a positive cycle and a negative cycle. So accordingly it will be converting that into the DC. So same the description is given how it converts a normal sine wave or an AC signal into a DC. So usage of each switch increases or decreases in voltage. Together they create a stair step wave. It is a wave that takes tiny steps to emulate the curve of a real AC wave. It is similar enough to the actual AC to power the motor. So it might not be so it would convert or if there is an inverter, then we would need to convert the DC of the motor into AC. So it might not be like very accurate AC wave, but it is stepped, but it would be termed as AC only when it is going when the motor is receiving it. So if you talk about the controller also, the controller are also defined as either they are sine wave controller or they are square wave controller. So how does sine wave, and if we are using a BLDC motor, then like we can even use the square wave controller also. We can use, the performance will not affect much. But if we are using permanent magnet synchronous motors, PMSM motor, if we are using, then it like we would require to have a sine wave controller only. So what does a sine wave controller advantages of a sine wave controller normally are a bit costlier than the square wave controllers. And the advantage with the sine wave controller is that if there are a lot of gradient where you have to where you have to drive where there are gradients, so the performance would be better if we have a sine wave controller. So and the sound that would be created controller, if it is a sine wave controller, it would be noise free, a kind of a noise free controller. But if it is a a square wave controller, it would make a noise. So when you go for a controller, when you to purchase a controller, the controller is defined, or it would be how would you identify a controller? It would be identified, if it is a square wave controller, it would be identified the angular, how much a 120-degree angle controller it is there, or what angle is there. So one is the angle, second is the current rating, so how much current, maximum current can flow through this controller. Second is the current rating, and third, if you speak about the number of the MOSFET that are inbuilt into the controller. So depending upon the current range of the controller, there would be the number of the MOSFETs. So they would be normally, they would be into the set of three, in the set of three. So as the current rating of the controller will increase, the number of the MOSFETs will also increase. So generally the maximum, if we are using an 18 ampere controller, then it will have 6 MOSFETs. So if we are using a 25 ampere controller, it will have roughly it will have a 9 MOSFETs. And if it is a 35 ampere controller, it will have 12 MOSFETs. For 40 ampere, it would be 15, 50 ampere, it would be 18 MOSFETs, and so on. So the MOSFETs will keep on increasing with an increase in with the increase in current, because either you use a very MOSFET with a higher rating, or you use a general MOSFETs, but you divide them, and they would be normally like in the set of three MOSFETs would be used. So the output you would divide on a set of 3 MOSFETs, you would divide. So this was like the first portion that this was we will also again have a additional session also on the controller. So this was the first session to give you an insight of how a controller works. So as from first slide onwards, we have discussed that controller is the brain of an EV. It receives the information through different components of the vehicle. It processes the information, and it gives it gives a signal, output signal, to different components of the vehicle to perform accordingly. So it is it is the it is the main component, as we said, that it is also the brain of the vehicle. And we have discussed the different types of the circuits that form the part of the controller. And designing a controller, if you speak about designing a controller, is equally designing any, you could say, any intelligent hardware comparable to a computer. It is very much comparable to a computer, because it has microprocessor into it. You can accordingly you can write a software, and which you could burn the microcontroller, which will perform accordingly. And at the same time, it could have safety features. You could also have a display attached to it if you require it. And also at the same time, you could have also have a communication port. So it could be through it could be done it could be done in the form of the communication can be either through cable, or it can also be through wireless communication can also be there. So all these are then can be the feature of a controller. So now we can take queries. So Rohit, we can take queries, in students who have query, they can raise their hand. I'll take 1 minute break. I will take. Okay, please, guys.
Okay, sir. Okay, sir. Sir, this is Renuka, sir, from Edify LMST.
Hi, Renuka. So 2 minutes, I'll take a break. So students can keep their queries ready, and they can raise their hands, and accordingly we'll be unmuting them, and we'll be resolving their queries.
Sure, Govinji, you take a break.
Excuse me for 2 minutes, please.
Yes. Okay, sir. Thank you.
Yes, hi everyone. So we can take queries one by one.
Angluri Uday has some query. Can you?
Yeah, Uday has a query. Renuka, if you can unmute
Yeah,
Uday.
hi sir.
Hi
So
Uday.
you have explained about the input devices for a motor controller. Sorry,
Yeah, yeah,
controller.
yeah,
So in that there is a PAS equipment. Can you
yeah.
tell me what are those? Sir?
There are.
PAS equipments like you have shown on slide in slide number 13.
Yeah,
So
yeah,
that is like input to the controller. So
yeah.
can you explain what are those?
So PAS can be like it can be like how much the vehicle has say driven, or how many kilometers the vehicle has driven, okay, and or at what speed the vehicle is driving. So those could be like PAS devices. They could be those. So they would only be giving you an information to the controller. Uh, you won't be you don't need any signal has to be given to them. So they could be like they could be sensors in a sense, like if there is a like rotation into the vehicle, they would be noting those rotation, how many has happened, and accordingly that would be converted into the form of how many kilometers the vehicle has run, or at what speed the vehicle is running. So they can be those devices.
So like can I say that like a odometer and indicators?
Yeah, indicator, or you can say like for speed you need a for a speed you can have a like meter. So they would be like at some point they would be like gauging in, and they would be like uh, they would be calculating like how many rotations has happened. So all those things they would be normally for like the speed of the vehicle, kilometers the vehicle has run. So in case of electrical vehicles, you don't need like any wire connected won't be there. So though they would be recording all those information, they would be recording.
Yeah, okay, sir. And one more thing about controllers, like
Yeah.
what are the trigger values to act the controller? Like for battery, what is the trigger value to act upon, and what is the motor? For motor, what is the trigger value?
So see, first of all, like controller, ignition is there. Ignition in a sense, like when you put a key into the vehicle, we switch it on. Okay.
Yes, sir.
Your console panel or the meter or the SOC that is there in the vehicle, that is switched on. Okay, so that from there an input signal will be sent to the controller, that and the controller. So the in case of electrical vehicles, the ignition that we speak about, the turning on the ignition means you are starting the controller. Okay, so first step is that. So when you have started your controller, now you're not started with the movement of the vehicle is as it is. Okay, so and you have just switched on the ignition and the controller is on. So the it will be receiving the it is connected to the battery. So first parameters that it will be studying is whether the battery is under voltage or not. Okay, so say if my vehicle is a 48-volt vehicle, so I will have a cutoff of 42 to 54. That we will be in description, we will be studying all these things in the battery, so you don't worry. So say if my range is 42 to 54, so controller will be studying that will be analyzing the voltage of the battery. So if it is 42 and above, it will allow the throttle to function, otherwise it will not allow the throttle to function. Say it is 45. 45 means it can like it is within the limit. So now you have started your vehicle, you move your throttle, so your throttle will start performing. When you rotate your throttle, the angle that which we will rotate, that the angle will be studied, will be converted into a signal from 0 to 5 volt. It will be converted and then it would be sent to the controller. controller will be accordingly taking the decision as how much output voltage it has to give. So that signal will be coming to analog circuit of the controller. That would be again will be converted into will be sent to the pulse width modulation circuit. Pulse width modulation circuit will generate a pulse. That pulse will trigger or will switch on the MOSFETs, set of MOSFETs that are there. Accordingly, there would be an output voltage. The MOSFETs will allow a particular output voltage to move to the battery, and the vehicle will attain the speed, according speed. So throttle, the manual, the throttle will result into the movement of the motor. Okay, so this would be happening very fast, so we will not be, but this would be the step-by-step process.
Okay, sir.
Sir, good evening, sir.
Yeah, Sai, good evening.
Sir, what about the voltage of the motor, sir, and the motor capacity, and how can we able to read the voltage of the motor and the capacity and also the battery?
So first of all, this voltage and capacity of the motor we will be discussing in the motor part, but then also to clarify, the speed of the motor is directly proportional to the voltage that it is receiving. Okay.
Okay.
And this voltage, the output voltage will depend upon the signal that the controller has received from the throttle. Say you are driving at a speed of 30 kilometers per hour. Okay. Now you see that you want to increase the speed of your vehicle. Okay. So what you will increase the throttle, or you accelerator that we call, you will twist it more. Say it was at some position, now you will twist it more. Okay. So so that twisting signal will be recorded by the controller, and it will analyze that to what angle you have you have angular twisting of your throttle. That angle will be converted into a signal. The signal will be received by the controller, and controller will be giving an output voltage, will be allowing an output voltage to the motor. Okay. So if it was driving at a 30 kilometer per hour, now you want to increase the speed to 40 kilometers per hour. So according, the voltage will also be we will have to increase the voltage also.
Okay, sir. Sir, any, for example, in the four-wheeler, sir, if any like sensors are being recorded for some sensors as a active sensors, in this two-wheeler, we can able to record what the sensor is being giving the ratio, sir.
What kind of like ratio you want to know? Like
ratio means the RPM or the total body or the speedometer sensor, or
those are all, everything is there into it. This first question that we speak about, there are sensors of like at what velocity the vehicle is driving. So in the meter you will be displayed some speed. Okay, say 40 kilometer per hour, and the vehicle has say driven to 5,000 kilometers it has driven. This is occurring because there are sensors which are recording this data. They are giving in some format to the controller, which are converting them into a viewable form. So when they are giving, they might be given in the terms of the RPM only. Okay. But because if you're driving and your vehicle is showing that it is driving at 1800 RPM or 5000 RPM, that doesn't make sense to you. What will make sense to you is vehicle driving at a 60 kilometers per hour or 70 kilometers per hour. So that input will be processed accordingly from the through the controller, and that will be shown on the display in a proper readable format that will be shown. Okay. So that will be done with the controller. So there are a set of sensors in the motor also. There is a sensor, and for speed controlling, for how many kilometers it has done, there are sensors. SOC, which shows the status of the battery, like state of charge, how much is the state of the charge, that will also be shown. So that is also done with the help of the sensor. So all these set of sensors are there in two-wheelers also, in three-wheelers, four-wheelers, or four-wheelers have much sophisticated more sensors, but two-wheelers have less sensor, but there are less sensors which are like for all purposes there are sensors.
Okay.
So like modern vehicles, there are in two-wheelers, if you speak about, now we have spoken about sensors, so I'll again add something to it. So say if the pressure level in your tires are low, so say there would be a pressure on the motor also, because it will be consuming more energy from the battery to run. If the pressure in the tires are low, so there are sensor which also records the pressure of the tires, and they will give you an indication that you need to like fill air into the tires. Otherwise, what will happen, it will result into more consumption of battery and reduction of your mileage. So that those kind of sensors are also there in the vehicle.
Okay.
If a vehicle fall down, if it inclines more than a certain level, then also your battery will be like your power from the battery will be turned off. That is also one of the sensor, and that is also available in the vehicle. So there are good like number of sensors in a vehicle, two-wheelers also.
Yes, sir. Thank you.
More queries, please. I think only very few people like in every session I can see only very few people, only students only asking question. So others like either they are not interested or they are not liking the session, at least they should tell me, because you should be asking more and more questions, or you are not understanding or anything, any issue is there, please let me know. So again, Uday has only raised his hand. He is again putting his query. No one. Kundan also want to ask again, but no new faces. No new faces are coming up with their queries. Any particular reason for this? You can like either put in the chat box also if you are not comfortable with
Sir,
yes, Uday.
about the controllers
Yeah.
for different type of motors, the controllers also varies, or we can use the same controller for any type of motor.
So we can use like, as we said that there are normally two types of controller, either a sine wave or square wave. Okay. So if you are using a BLDC motor, brushless DC motor, then we can use any type, like we can use either square wave or sine wave. But if we are using permanent magnet synchronous motor, okay, so for them we have to use only sine wave controllers only. Okay, but we have to be very careful about the voltage setting. See, if you are using a 48 voltage like controller, it won't be useful for a 60 volt or a 72 volt vehicle. So voltage has to be seen, like the maximum current setting that has to be seen, either it is a square wave or a sine wave, that has to be seen. So these three are the the most important parameters which you should see before like using a controller.
Yeah, okay, sir.
So, like Shruti has asked, what are the 4 circuits included in the controller due to network issue? I was not able to listen. So, Shruti, the most important like circuits that there are in the controller, first is the analog AD circuits or the analog to digital circuit. So what does this do is the analog signal that is received through a throttle, it will convert into a digital signal. And second is the pulse width modulation circuit. So this digital signal will be transferred to the pulse width modulation circuit. What pulse width modulation circuit will do, it will generate a pulse, okay, of a certain duty cycle. It will generate a pulse. This pulse will be used by the MOSFETs to trigger the MOSFETs to allow a certain voltage through them, so that when a vehicle has to increase its speed, the vehicle speed would be increased. So analog digital circuit, one of them is analog digital circuit, pulse width modulation circuit is there. Third and fourth, third is the power circuit. Power circuit also the input that it received from the battery, that forms the power circuit. And fourth is the overcurrent and under voltage circuit. Is it okay, Shruti, or you want to ask, like you want to? I'll try to like unmute you. 1 second. Yeah, Shruti, you can unmute yourself and you can like, if you want to ask, you can ask the question. If you have further query, or we can take the query from Lakan.
Good evening, sir.
Yeah, hi. So Lakhan, 1 second before this, let me, Shruti has asked overcurrent and under voltage cut used as safety. Yes, Shruti, the overcurrent and under voltage are used for the safety parameters. Yes, Lakhan, you can ask.
Sir, if controller stops giving signal or receives signal from the devices, or whether it is motor.
I can't hear you. If you can speak a bit louder, Lakhan.
Sir, if a controller stops receiving signal or sending signal to the devices,
Yeah.
if the vehicle will run or stop, sir?
Yeah, it will stop.
It will stop, sir.
If it is not receiving signal from the throttle is cut off, then it will stop. Students, if you have any query, you are free to ask, or you can, even if you're not comfortable like speaking, you can like put your queries in the chat box.
Yes, students, and because tomorrow, like a case studies is there, okay? So if any queries is related in case studies, also you can ask to sir.
So students, if there are no queries, unfortunately, what we have to do is we'll have to wind it up. So anyone want to ask anything, please? Sai Kundan has raised his hands. Renuka, if you can like unmute him.
Sir, it has been unmuted, sir.
Yeah, yeah. Hi.
Sir, any live demonstration of the sorry, sir. Like we can able to see live demonstration in the OBD port, sir, while connecting the systems in these vehicles.
Or like what kind of output you want to see? You tell me any parameters you name.
Yes, parameters like battery voltage in a running
Yeah,
condition.
battery voltage, definitely there is as we see the petrol, like how much is there in the tank. In the digital format, it will always be showing you the battery conditions, like SOC that we call, state of charge that we call. Okay.
Yes,
So
sir. Yes, sir.
that will be always shown. So that can be either shown in the form of the percentage that we see in our battery, in our mobile battery, that we see that 100%, 20%, 5%, 7%, that will be shown in your vehicle. That can, the format can be different. It can be in the format of the percentages, or it can directly be straight away, it can be in the format of voltage. Like the battery is has this many voltage. Like if it is a 48 vehicle battery, then it can show you voltage from 42 volt to 54 volt. So it will directly show you volt. Or it can be shown in the form of the bars. Like it is if it is like how many, say if it is showing in through four bars. So if it is only 3 bars are showing, we can see that it is 75% charge. So in the display can be different, but definitely it is this is a very like the basic features, and it will be shown in all the vehicles. Okay.
Sir, can we record the onboard diagnostic of the vehicles, sir, of two-wheelers?
Onboard diagnosis.
Yes, sir.
Yes, definitely. You can see, as I spoke about in between, that you can like make your controller such that it can emit like information, or it can emit data. Okay, so if you are remotely sitting somewhere and your vehicle is functioning, say in other cities, so you with the help of the set of data, definitely you can find it out what is the issue going on. So say if your vehicle has suddenly stopped, it was moving and vehicle has suddenly stopped, and the person who was driving, he gives you a phone call and says that my battery is still 60% it is showing, but the vehicle has stopped. So what could be the condition of the vehicle? You found out that the temperature of the controller is much higher than it should be. So why the temperature has raised? Either say there is an issue with the braking system, the brake pads have not been released, that is causing it to exert more, or there could be an issues like more people are sitting on the vehicle, 3 people were driving. So like through these set of data, you can correlate and you can find it out what could be the issue.
Okay, sir. And we can do practical things on the campus, no, sir, on this vehicle?
Yeah, practical things. You can open it, you can assemble it, reassemble it. You can yourself, with the help of you, with your hands, you can like experience all the components and everything you can do.
Okay, sir. Okay.
Lakhan has raised his hands again, I guess. Renuka, if you can like unmute him.
So
Yes.
it's already clarified, sir.
Hello.
Already you have clarified, sir.
Okay. So anyone else who want to ask queries? So till now, if we talk about, we are done with 7 sessions, and there are students who have not asked a single query. So we are guys, we are also recording those data also. So you should be like proactive. You should be asking questions also, at least so that we come to know that yes, you are paying attention. Any sort of query, even if it is water DC motor controller. Shiva Nayak has asked what is water DC motor controller. So Shiva, like controllers, as as we have spoken in this entire session, that controllers are the brain of the vehicle. They receive information, processes them, and then gives different signals to the different components to act accordingly. Okay, so if you want to increase the speed of the vehicle, the input signal will be received from the throttle, it would be processed, and an output voltage accordingly output voltage will be given to the motor to increase the speed accordingly. If there is an like undervolt or overcurrent situation is that would also be recorded by the controller, and the vehicle the controller would be cutting off the supply from the battery. So protection, vehicle performance, receiving information, processing them, and sending it to the different components for a proper functioning of the vehicle is what a DC motor controllers do. Have I been able to answer your query? So DC motor controller, in a sense, like they would be controlling the DC motor. Main purpose, primary purpose will be the controlling of the DC motor, but at the same time, other functionality, other protection of the vehicle will also be taken care of by the controller. Anyone else who want to ask anything? So anything, even from the previous sessions also, if you have query, we have another 4-5 minutes we have where we can take them also.
Students, anyone is having a queries related of in case studies, please, because we are receiving some queries from the case studies part, sir.
So Venkatesh has asked, sir, is regenerative braking similar to SHVS? So Renuka, if you can unmute Venkatesh, like I'm not getting, if you can like expand what is SHVS. If you can unmute Venkatesh.
Yes, sir. Venkatesh, please unmute your mic.
So regenerative braking, smart hybrid system, if you speak about, see, that can have different meaning, like Venkatesh, to be very frank. Hybrid, hybrid, if you talk about normal term hybrid, it means that it would, it can it can have like two sources of power or two types of performances, and all those things can be we can include under hybrid. So if regenerative braking, if I speak about the basic concept of regenerative braking is, instead the energy during the braking, the energy that is lost in the form of the heat, we are tapping a part of that energy to convert into a usable form. We will be redirecting that energy in the form of the electrical energy for the charging of the battery. So 5 to 6% of that energy, which I either would have would have been lost in the form of the heat, we have utilized that energy and we have increased the mileage of our vehicle. Okay, so this definitely this energy was taken from our battery only, but what would have happened in absence of regenerative braking? This energy would have been lost, okay, in the form of heat. Now what we have done, we have made this part of this energy a usable format, and which we have used for charging our battery. And if our battery has been charged, say 3-4% also, then we have been able to use it in driving our vehicle to a much like to a higher duration, or we can say we have increased the mileage of our vehicle. So definitely this is we could say, yes, this is a smart solution, but a hybrid I won't say, because it would have been hybrid if the regenerative would have happened by two processes. Okay, if I would have used two sources for hybrid for regenerative braking, then we could have called it hybrid, but it is a smart solution. Definitely it is a smart solution. Venkatesh, are you clear, or you want to, you can unmute yourself and you can further tell me if you have any query. So any further queries? Otherwise, we will have to wind it up now, guys. We'll wait for another some few seconds if anyone is coming up with another query. Otherwise, we will have to wind it up.
I think there is Sai Kundan and Lakhan has hands up.
I think they have we have already clarified them. We can Sai Kundan and Lakhan, if you can type it out if you are still left with some query, or you have already asked your questions.
Sir,
Yes,
that's it, sir. If anything is there, I will able to do tomorrow in the class, sir.
yeah,
If
you
any
can
doubts.
you can again recall anything if you have tomorrow. Definitely we'll again be taking the, no issues from last any session. If you feel like asking, you can record it, write it. Definitely you can ask it anytime. No issues with that.
Yes, sir. Yes, sir.
Lakhan, if you I think you are done with your query.
Can I ask one thing, sir?
Yeah, please.
Sir, if a vehicle met with an accident, does it show the
Lakhan, if you
damage?
can speak a bit louder, your voice is very very low.
Now audible, sir?
Yeah, please speak a bit louder.
Sir, when a vehicle meets with an accident, does it show that how much damage happened to the vehicle?
How much
Damage happened to the vehicle, or any other parts got damaged?
I did not I was not able to we are not able to hear you properly. If you can speak a bit louder, then it would be good.
So now audible, sir? Hello?
Audible, but speak a bit louder. Like when you are asking a query, something gets missed out.
When vehicle meets with an accident,
You okay?
it gets damaged now, sir.
Okay.
Will it show the damage percentage, how much it has damaged?
See, physical damage, definitely it will not be showing. If there is any change in the battery parameters, those also in the form of the voltage, that it will be showing it. Otherwise, physical damage, it will not be showing it, to be very frank. And
As a part,
when it meets with an accident, you will have a physical damage only. Hello.
yes, sir.
So mostly there would be physical damages. So only if there are some, say, if the wire is cut off, say my throttle is there, if wire is cut off, then it could show that portion. It could show that the throttle it will give an indication of a throttle. Okay, so the throttle is not okay, or it is not connected, then it will give an indication. Say if your motor is disconnected, or it is it is not it is not communicating it with the controller, then it will give a signal of a motor. That means your motor has an issue. So these 4-5 indication would be there, but any physical damage will not be indicated.
Thank you, sir.
Have I clarified, Lakan, or
Yes,
you want?
sir. Yes, sir. Yes, sir. Clarified. Thank you, sir.
Okay, so one second, there is a query in the text box. Dinesh has asked, how many controllers can EV carry? If controller is not working when we are driving, can we use any another controller like backup? See, it is again a component only. Dinesh, if you can maintain as many controller as you want, but definitely either you have to get you will have to connect them. So it is not normally not advisable, and since there are very less moving parts in the controller, the damage or the probability of controller being damaged is much lower than the breakdown of the motor. Okay, so normally maintenance of a controller or a dual controller is not needed normally. Okay, so you could call it a space constraint because of costing also, and like at the same time, either if you want to have a dual, that will also not serve the purpose because it is a static device. The cases of it being not working is lesser than motor. So first, some other part will be damaged, then it will make an effect on the controller. Okay, so maintenance of a backup controller is not advisable. Am I clear, Dinesh, or you want to ask further? You want to ask anything?
Yes, sir. Clear, sir. Thank
Yeah, hi Dinesh.
Hi, sir. Thank you, sir.
Okay, okay, okay. So Renuka, like I think we have like answered all
Yeah,
the.
let's conclude the session, I believe.
So
Yes.
we can conclude for today and look forward to session tomorrow.
Tomorrow we have a 2 session.
Yeah. And
Yeah.
tomorrow, like students, I think they will be judged for their case studies also. So
Yes, sir.
they
Yeah,
should come prepared.
Yeah, some of the groups, they already prepared, so
Yeah.
some people is going on.
Yeah, very good. And students, you already still have a lot of time. So give your energy, give your time to the research, and you should be like aware of like what's happening in the topic. Should be aware of with through a thorough research. You should be like aware of happenings like for the topic that you have been given. That will not only enhance your knowledge, also you will also come to know what are the like general trending that are going in the EV industry. So Renuka, like we conclude for today in that case.
Yes, sir. We'll just go.
Okay. Thank you, students.
Thank you so
Thank you very
much.
much. Yes, Nabangsuji, yes.
Thank you. Let's meet up tomorrow, 4:30, right?
Yes, sir.
Right.
Yes, sir. And thank you so much, sir. Okay, Govind sir and Navanshi sir, and for all students. Okay, thank you so much.
Thank you, Renuka. Thank you to you also, like to be there as a co-host, and thank you to all the students. And again, last request to all the students, please ask queries that will help you. So look forward to session tomorrow. Thank you, everyone.
Yes, sir. Thank you. Thank you, sir.